Alrighty. Alright, we're back. Yes. Alrighty. Got a few people coming in. There we go. Alright. How's everybody doing today? Morning. Morning. Robert and Samantha here. Very good. How are you guys doing? Got a few things to do this morning. Hopefully, you've finished up the test there. Good. I'm doing pretty good. Good morning. How are you? How we doing, Carissa? We're doing a rise and grind gamer. Yeah, that's true. That's true. We're on the website for gamers and educational nerds like me. welcome to the corner of Twitch. Our corner of Twitch. To learn things. Good morning, Hisa. How are you? Oh, okay. Pretty good. Pretty good. Doing well here. So far, so good. Knock on wood. Good. I'm very good. Can we talk about how to upload pictures from a phone onto D2L? Well, you just have to upload the pictures to your PC, and then you could take your pictures from your PC there, and then put it as an attachment to your the assignments on D2L, the assignment link for the test there, and then you can do that. So all you have to do is just somehow upload the pictures from your phone to the PC, and then from PC you can upload that to the assignments on D2L. It should be good. Oh yeah, that's a good idea too, actually. That's a really good idea. That's even better than maybe what I suggested. Okay. Oh yes. Okay. Okay. I'm gonna get started here. All right. Okay, let's get started today. Welcome back to Tuesday. Hopefully, have a nice weekend. So today, all right. So today, uh, we are going to be talking about. Let me see. Hang on a second. All right. So today, what we're going to be talking about here is we are going to be talking about several things. We're going to finish up where we left off last time. Last time we talked about factorization. All right, and so we're going to go ahead and continue moving on with some factorization. Okay, nothing too fancy, mind you. So we're going to do the latter half of that section. If you recall here, we talked about prime and composite numbers. Okay, so we're going to start with that. We're also going to go ahead and do the next section here, section 2.4, which is talking about fractions, writing them in lowest terms. And then we'll get to a little bit of multiplication of fractions. We'll just start that particular section there, but obviously not finish. We'll resume there for next time. So that's what's on the docket here for today. Now, before we go ahead and get started here, again, as a friendly reminder, remember that Chapter 1 homework is going to be due today as well as the test. So be sure that you get those done, excuse me, by 11:59 tonight. Okay, so that is something you'll need to get done here by the end. Okay, all right, so let's go ahead and get started here with talking about what we did last time here. Now, last time we discussed what prime numbers are and composite numbers and what they were. And we said, all right, what are prime numbers? Yes. Uh, so prime numbers here, numbers whose factors are itself and 1. So an example of a prime number is 3 because only 1 and 3 will divide 3. Okay, no other numbers divide 3 but those two. Okay, composite numbers are numbers whose factors include other numbers outside of itself and 1. So an example of that uh, is going to be that example of that is going to be 6. So 1 and 6 obviously divide 6. That happens by default. But also numbers 2 and 3 are also divide 6. So that's why 6 is a composite number as well. Okay. All right. For 1.10, that's going to be due with the Chapter 1 homework. Okay, so that's due today. All right. So that's basically the breakdown of a prime and composite number. Now, what we're going to do here today is we're going to be talking about prime factorization. So we're going to take some numbers here and we're going to break it down into its prime factors, okay? So we want to break it down into 2 and 3 and 4 and 2 and 3 and 5 and all those other guys. Right? That's what we want to do. Okay? So, let's go ahead and talk about the key about how we can go ahead and break these numbers down into its prime factors. So we'll go to the handout here. Go back up here. Okay. All right. So the first thing we'll do is let's find the prime factorization of 12. All right. Now, for us to do this, let's go ahead and bring that back. Poof, and poof. All right. So for us to go ahead and do this, we are going to use a factor tree. Come on, get close. Okay. All right. Anyway, we're going to go ahead and use a factor tree to see what the prime factors are. All right. And so let's go ahead and do that here right now. So we're going to put 12 up top. All right. So 12 is going to go up top. And we're going to break this down. Now, maybe you've seen factor trees before. Okay, and if you've seen factor trees before, this is not going to be anything different, but each of these guys here that I'm drawing out for the factor tree are branches on the factor tree. Now, what we want to do is we want to break down the numbers so every number on the branches of this factor tree are prime numbers. Okay, now the only thing we can't do is that we have to keep going or breaking down if the branch is a composite number. However, we do not break the number down to 1 and itself. So if we see 12, we're not allowed to use 1 and 12 because then we just get right back where we started, and then there's no point. So you could keep doing that forever. All right. So let's think of two composite numbers, or two numbers actually. And again, they can be simple. You could pick any combination of numbers so long as those two numbers there multiply to 12. Okay, so let's pick two numbers there. What are two numbers that multiply to 12? 6 and 2, right? All right, so we could pick 6 and 2. Okay, now you could pick any combination, so you could have also picked 3 and 4. Okay, if you're having connection problems, hit F5. Okay. Today I lowered the quality of the stream so it would have less connection issues. So okay. So we have 6 and 2 here. Now, one thing that we do know here is what we're going to do is we're going to circle 2. Okay? So we're going to circle 2 here, and 2 here is a prime number. Okay? So this is where whenever we circle a prime number, that's where that particular branch is going to stop. However, 6 on the other hand is a composite number, so we can break that down even further. And what does 6 break down into? All right, 3 and 2, that's right. Very nice. And we know that 3 and 2 here are prime numbers, so we're going to circle 3 and we'll circle 2. And each one of these numbers here is a prime factor of 12. So 12 here is going to equal 2 times 2 times 3. I just wrote this in numerical order. So all the circled numbers that you see here. Another way that this can be expressed, and something that you may see in the homework, is you may see this written as 2 squared times 3. So sometimes they'll ask you to write this as 2 squared times 3 as opposed to 2 times 2 times 3, but in reality it means the same thing. Okay. Are there any questions about that so far? No? Okay. Let's try another number. Okay, let's try another number. This time you guys guide me. So I'm gonna do we add it all together? No, we multiply it together because we're breaking it down. We're kind of dividing things out one piece at a time. So if you notice here, we are multiplying here in this case. So 2 times 2 times 3, or 2 squared times 3, are both equivalent forms of the prime factorization. So just talking multiplication terms here. Let's go with 60. We'll do another example here, so we'll show this off here. All right. So again, let's break this down into two numbers. Okay, you can pick any two numbers you want, by the way. So as long as they multiply to 60. So what two numbers multiplied together equals 60? Okay. Yeah, there's a lot of combinations. I agree. 15 and 4, 6 and 10. All right, since 15 and 4 was put first, we're just going to roll with that. But you could put 6 and 10, and that would be acceptable as well. Okay, both are perfectly fine. I'll show you the 6 and 10 over here as well. So I'll do both. And I'll just show you get the same answer regardless. You could have picked 2 and 30. That would have been just as acceptable. So a lot of different combinations. 3 and 20 would have been an acceptable combination. There's a lot, like I said, a lot of different combinations to get to 60. I'll start off with 15 and 4, and then we'll do 6 and 10. Okay. 15. What does 15 break down to? Okay, 3 and 5. Right on. Very good. And how about 4? Two and 2. Perfect. All right. So if we circle these, all right, 3, 5, and 2, they're all prime factors. I'm going to circle all of them. This is where this branch stops. So here we have, I'm going to put this in numerical order, 2 times 2 times 3 times 5. Or again, another way to express this is 2 squared times 3 times 5. So this would be the prime factorization of 60, again using 15 and 4. Let's see if we get the same result here using 6 and 10. So with 6 and 10, this will be 2 and 3 or 3 and 2, whichever way you want to write it. And the 10 here will be 5 and 2 or 2 and 5. So we'll just go ahead and circle stuff. Circle this, circle this, circle this, and circle this. So we're going to have 2 times 2 times 3 times 5. So that's the exact same thing that we got from before. Okay, so that checks out. Okay. So we had, again, same thing here. Get the same exact factors no matter which combination that we go with, as long as we break it down appropriately. Any questions about that? None. All right, fine. No. All right. Okay, we're going to go ahead and do one more example from here. Because sometimes what can be a little difficult to find your factors of particular numbers here. So let's go back here for just a second. Is we've done most of this part here, but let's say I had a larger number. Let's say 225. Okay, so let's say we had 225 and we wanted to go ahead and find out, what the factors of that are going to be. So let's do that. This will be the example here. Okay. So if you're not sure, because it's a large number, like 225 or, some other crazy high number, just start off with something basic and then kind of work your way down if possible. So, you could pick any number. If it's an even number, you could start with 2, or again, you Start with simple numbers if you need to. Or again, if you know something that's bigger, then you can go with that combination. So there's a lot of possibilities there. The 25 and 9, I would agree with that. 25 and 9 is correct. Now, if you want a tip here for you guys, a very easy tip. How do you know it's 25 and 9? The way that I think about 225 is anytime it ends in 25, 50, 75, or 00, all I think about is how many quarters in that particular number. So for example here, how many quarters in $2.25? Right? 75 and 3 would be correct as well. I think of it in quarters, like actual practical money. So I'm like, okay, how many quarters in $2.25? Yeah, and they're 9 quarters in $2.25. So 25 times 9 is the way that I look at it. I always, yeah, I do the same thing you do. Is I always say, oh, well, how much is this in $10? Okay, I know that they're 4 quarters per dollar. So, okay, now I know what to do with that. There's 4 and 8 and 9 will be one more quarter, will be 225. So, that's what we have there. All right. Let's break down 25 and 9. 75 and 3, like Robert said, just as acceptable. Um, how can you break down 25? 25 of 5 and 3. So 5 times 3 is 25? Oh, 5 and 5. Oh, okay. Oh, okay. I was like, woo! All right. All right, how about 9? All right, 3 and 3. All right, it's not too bad. Okay. All right, let's circle the 3s and the 5s here. So here, if we break down 225, that's going to be 3 times 3 times 5 times 5. And so here we're going to get 3 squared times 5 squared. And that will be our final answer if we write it in exponential form, or 3 times 3 times 5 times 5. All right, any questions about that? All right. If there are no questions, we're going to go ahead and move on. Okay. So, let's talk about the next section here. Okay, so the next section here, oops, I wanted my Word document. Okay. So the next section here is talking about writing fractions in lowest terms. Okay, so the first thing I put here is, what does lowest terms mean? Lowest terms mean is when the numerator and denominator do not have any common factors with each other. Now this is really important here. What do I mean exactly by that? Let's look at one example here about where you have, say, lowest terms. So if I have, let's say this is my fraction here. I have one number in the numerator and one number in the denominator, okay? Numerator being the top and denominator being the bottom. Okay, so we have, let's say I have 11 over 24. Now, what is true is that you could break down 24 into different factors, like, 3 and 8 or 2 and 12 or whatever. But, 3 divides 24 just fine, but 3 does not divide 11, so I can't reduce it down there. If I try 2, 2 doesn't divide 11, so that's a no-go as well. I can try 6, that doesn't work. 4, that doesn't work. 8, that doesn't work. That doesn't go into 11 evenly. So the key here is that they do not have any common factors with each other. So although this can be broken down, they both have to have the same common factor in order for us to reduce it down appropriately. Okay? So let's look at an example here, and let's talk about how we can go ahead and find what the reduced fraction is going to be. Okay, so let's start off with 18 over 24. Now, just to showcase this in the book here. So we're gonna do this this first part here of 18 over 24. If you see here on this page, 18 over 24, according to this, is equal to 3/4. And so what we're going to showcase here is exactly how we get to 3/4 here. Okay, and I'll do it in a couple of ways. So I'm going to do this problem out, and I'll show exactly how this works. Okay, now the important part here about this particular problem really stems from two things. All right, the first thing is the key. Now let's talk about the key here to this problem. The key here to this problem is basically the key to all of algebra. The key to all of algebra is the word balance. Okay, what we do on the numerator is what we do on the denominator. We have to make sure that we balance things out. So in a sense, what we're doing here is this. We're going to find the common factor that we can divide by on both the numerator and denominator to reduce the fraction. And again, you can't mix and match numbers. They have to be the same exact number. Okay, so we're not allowed to just kind of mix and match. However, one thing to note here is that you may need to do this multiple times. So maybe we reduce it down by one number, and maybe there's another number in common between the numerator and denominator that we can go ahead and reduce down with. So that's certainly possible to have like 2 or more steps. That can happen. Okay. So in this particular case, let me do it 2 ways here. All right. So the first way that we can kind of approach this is let's divide by, in this case here, we can divide by 6. All right, let's divide by 6, since 6 is a common factor between 18 and 24. And all I'm going to do here is divide straight across. So now that, because I have, as you can see here, I'm dividing 6 on the numerator, dividing 6 on the denominator. So 18 divided by 6 is 3. 24 divided by 6 is 4. So here we get 3/4 as our answer here. Again, this is where we stop because 3 and 4 do not have any common factors in common with each other except for 1, because everything does. So 1's always a common factor with everything, and it does nothing. All right, but let's take a look at another way. Okay. So let's say, for example here, let's say you don't know, okay? You're not sure what common factors there are. Well, again, just like we talked about the factor tree in the last section, just start small and work your way up. Let's just do that. We see 18 and 24, for example. We say, okay, well, they're both even numbers, so how about I pick 2? Okay, so I'm going to just start with 2 and see what I get, and then see if I have to reduce it down again. So in this case, I do 18 divided by 2, which is 9, and 24 divided by 2, which is 12. And then we ask the question, okay, let's look at 9 and 12. Do they have any common factors? And the answer is yes. I could divide by 3 on the numerator and denominator. 3 goes into 9 3 times. 12 divided by 3 is 4. So once again, we get 3/4 as our answer. Okay, so you can see here, you could take multiple steps if you need to, if you want to work slow, or if you want to work faster, if you see a bigger number that's in common in the numerator and denominator as a common factor, then you could do that as well. All right, any questions about that? No. All right. I'm going to do a few more examples, of course. So lots of examples in this section. So, okay, let's go ahead and do another one. All right. All right. Let's go with this one here. All right. Okay. We'll do 21 over 36. Okay. So can anybody tell me, does 21 over 36 reduce? And if it does, what number can we divide on the numerator and denominator? Okay. The answer is yay. And divide by 3. That is correct. Now, once again, if you're not sure that 3 is your answer there, go ahead and take a look at your times table, and you'll see that 3 is indeed a number in common between 21 and 36. Okay, let's look at 21 divided by 3 and 36 over 3. What do we get as our answer here? Okay, good. So we indeed get 7 over 12 here for our final answer. Again, 7 and 12 have no common factors, so that's it. 7/12. Let's go ahead and try another one. Okay. So let's try this next one here. How about 30 over 50? What can we reduce that by? Divide both by 10. Okay, good. All right, I agree with that. And we get 30 divided by 10 and 50. All right, 5. 5 on the bottom there. Okay. And what do we get up top? 3. Okay, good. Put that together there. Good. You could divide by 5 here, by the way. So, again, you could go in steps here. So if it's like, if you don't see 10 right away, which is fine, you could divide by 5 here. So we get 6, we get 10, and then you could divide by 2 to get the 3/5. Both ways, just as viable. Okay, so not too bad. Pretty straightforward. All right, let's do the next one. More problems. Oh dear, that's not what I want. Okay. So let's look at that next one there, 60 over 72. So 60 over 72, what's that going to be? Okay, and how did we get that? What did we divide by? Okay, 12 is a common factor, that's correct. Okay, now if you don't see that right away, that's okay. You could pick 2 to be your first common factor, or you could pick 6. Both of them are just perfectly fine. Again, this is where we get, again, 5, 6 here as our final result. So again, you could pick, let's pick 6 as our common factor, for example. You would get 10 over 12, then divide by 2 again, and you'll get the same result. Why did I do this? I meant 5. Okay. Yeah, you could take it 2 times, of course. Everybody gets 2 tries. The best score is the one that's recorded. So if you're not very satisfied with your first score, Samantha, you could take it a second time and then see what you get. I've set it up that way, so everybody gets 2 chances. Should be pretty straightforward, I promise. Okay. Okay. All right, some of these fractions here can be rather large, so all right, I'll let you work on some of those. All right, actually, it's not a bad idea. Let me try that. Yeah, we're kind of buzzing through. All right. Okay. All right, so the next thing I would like you to try is, let's have you guys try a problem for yourself. We'll try 124 over 340. Okay, so let's try 124 over 340. I'm going to ask you to reduce this down. So let's take a minute or so and see if we can reduce this particular fraction. That's 3. Let me check again. I think that's 340. Yeah, it's 340. 340, Robert. Let me fix that. Yeah, no problem. Make that a little more clear. Okay, we got 31 over 85. All right. All right. Also got 31 over 85. Okay, so we tried it out. Wait another 30 seconds or so. See if we get other answers. Okay. Okay. All right. That's fine if it take you a little more time. That's not a problem. We'll go through this carefully, nonetheless. All right. So first things first here. I just took it as a simple approach here. I was like, okay, you know what? These are even numbers, so I'm just going to go ahead and divide by 2 because they're pretty large and I can't really think of a number that's in common between them. So I say, okay, well, let me take 124 divided by 2. And so here you're going to get 62. If you take 340 divided by 2, you actually get 170. Now I look at it and say, all right, let me divide by 2 again, because again, they're both even numbers. So on the top here, we get 31 on the numerator. Denominator here, we get 85. And yes, that is correct. 31 and 85 have no common factors. 31 is a prime number anyway. So there we go. We got it. And that'll be our final answer. All right, any questions about that? Okay. Let's do the next problem here in the handout then. Okay, so what we're going to do next here is we're going to determine whether fractions are equivalent or not. So we're going to be given a pair of fractions and we want to determine, say, hey, are they equal or are they not equal? All right, that's basically kind of what we're focusing on here. Okay, so let's try a couple of problems then, and let's see exactly what we're working with. Okay. Okay. So let's look at this first pair of fractions. Okay, so we have 16 over 48 and 24 over 72. Let's take a gander at that. Okay, so let's put both of those down. So we have two fractions here. All right, and if we're going to find out that these two fractions are equivalent, that they're equal, then they should be equal to the same reduced fraction after everything is said and done. Once it is, then we should be good to go. Okay, so let's take a look here at this first one, 16 over 48. What can we divide by in order to reduce this fraction down? 4. Okay, let's go with 4. So I'm going to divide by 4 on the numerator denominator. So 16 divided by 4 is 4. 48 divided by 4. Good, 12, right. Okay, nice, nice. Now can we reduce this down further? We have 4 over 12. Can we reduce this further? Yes, okay. What should I divide by then? 3. Okay, good. Not 3, wait, 3? Oh wait, no, 4, okay. Wait, I know what you're thinking. I think you thought one step ahead there. But that is correct. So you get 1/3, okay, good. Okay, so we got 1/3. So our expectation is that this second fraction should also be equivalent to 1/3, okay? If it's not, too bad, so sad, they're not equivalent fractions. So let's take a look here at this second one. What should I divide by here in this case to start? All right, 12 or 6, both are okay. Fortunately, you have a lot of flexibility. So we have 24 divided by 12, which is 2, and 72 divided by 12, which is 6. Can we divide by anything else now? Divide by 2. Okay. We get 2 divided by 2, which is 1. 6 divided by 2, which is 3. Okay. There we go. And we got 1/3. So both of these are the same. It checks out. They are equal to each other. I was going to say, divide 8 by 2, I'm like, man, holy cow. I mean, I had no idea, but now I do. I'm learning new. I'm learning new math every day. Every day I learn new math. Oh man. All right. Good stuff. That's hilarious. Okay. Let's do one more problem here from this section. Okay. Then we'll move forward. So let's do this other one here. So we're going to have 20 over 4. All right. And 110 over 22. All right. So we have 20 over 4 here. What can we divide by? In this case, to reduce the fraction. Oof. All right. We could divide by 4. I agree. So let's divide by 4 on the numerator and denominator. Nice. So we're going to get 5 over 1. Okay, so this is our expectation. Our expectation here is we should have 5 over 1 for our second fraction once we reduce it down. All right, so this first part here, pretty straightforward, pretty simple. But we have an expectation now on the table. Let's take a look at 110 and 22. What could we reduce by here in this case? All right, 2. 2 is a good start. If you're not sure, go with something simple, something small. That's fine. It's bigger. Okay, now if we do the bottom part here, that's going to be 11. So 22 divided by 2. And then we have 110 divided by 2, 110 divided by 2, if you figure that out, it will be 55. So you have 55 there. All right. Anything else we can divide by? 11. Good. Yep, that's correct. So we get 5 over 1. So once again, this checks out, and they are indeed equal to each other. So we did it in 2 steps that time, but that's okay. You can make this nice and easy. You have a lot of flexibility. You don't have to get it all done at once, but you have a lot of flexibility about how you want to reduce down your fractions. And that'll be important there. So if you like taking the small steps approach, that's fine. If you like taking a large leap approach, as long as you divide by each number and they divide evenly, you're also good to go as well. Okay. Okay, any questions about that? No? Okay. Okay. Let's go ahead and so that is, let's see, that's the end of section 2.4. Okay, we're now going to get into section 2.5 here. We're just, like I said, we're just going to start with this, but we're just going to do like maybe a couple of examples, and then that's where we're kind of end off here for the day there. So but let's talk about multiplying fractions. Now, multiplying fractions is going to use one of the concepts, the concept that we talked about in this last section about reducing fractions. Okay, so we're going to multiply two numbers together. You magically get something on the numerator and denominator, and then afterwards we can reduce it down if we feel that's necessary. Now, the thing is, in regards to this, specifically, let's go back to our Word document here for a moment. All right, there is a rule for multiplication of fractions, okay? And the rule is pretty simple. It says, here's the rule. If you have a over b times c over d, then that's equal to a times c over b times d. Now, that's a pretty simple rule. You're just multiplying straight across, and you don't have to put a lot of thought into it. And then after the fact, you have to reduce it down. However, that's not what we necessarily want to do in these problems. Instead, what we want to do is what the key is listed here as is we want to reduce before we multiply these two fractions together. If we're able to reduce it down, we don't have to do all the extra work after the fact. We can do it before the fact with smaller numbers. Okay, so it's much easier to start dividing things out or paring things down. Okay. All right, let's go with this. Okay. All right. Did, okay. Okay. Okay, just want to make sure. Stream stopped there for a moment. Okay, you had to refresh. Yeah, sorry about that. I'm not sure why it froze like that. Nah, you're good. You're good. You are good. Okay. Okay. There we go. Got it. All right. So what we're doing here next here is just multiplying straight across. Let's go ahead and take a look at this problem here. So here we got 5/8 times 3/4. So all we're doing here is just multiplying 5 times 3 over 8 times 4. And then you'd be like, okay, well 5 times 3 is 15 and 8 times 4 is 32. And we just simply ask the question here. We say, all right, we say, okay, what is there anything that we can reduce down here of 15 over 32? Okay, so that's the question that we have here. Is there anything that we can reduce down here between 15 and 32? No? Okay, that's correct. There's nothing in common between 15 and 32. All right, so this is where we effectively stop, and this would be our answer. Now, let's try another problem where that may or may not be the case. Okay. Okay, so let's do this next one here. Okay, so here's the next one here. We have 3/5 times 1/3. Now if we put this together, we get 3 times 1 over 5 times 3. But here's the trick to this problem. The trick is that I don't want to multiply straight across to begin with. What I want to do here is to see if we can divide anything out, okay, in order to acquire our final result, okay? So do we have a common factor in the numerator and denominator that we can divide out? In this case, the answer is yes. We have a 3 in the numerator and we have a 3 in the denominator. So we're going to divide each one by 3. So here this 3 divided by 3 becomes 1, and this 3 and 3 also becomes 1. And so here we get 1 times 1 over 5 times 1, which is 1/5. Okay, so that's how we're able to come up with that particular answer. Okay, now let's go ahead and do one more now that we have a little bit of a template for that. Let's make up one more and we'll see if it works. Okay, so we have 3/4 times 8 over 15. Okay, so here's what we have here. 3 times 8 over 4 times 15. Is there anything that we can reduce here on both the numerator and denominator here? Excuse me. don't think so. Anything that we can pare down here? Are there any numbers that are in common? What can we divide out on the numerator and denominator? 3 and 15, okay, that's correct. What can we divide by there? Okay, 4. So we can divide 4 and the 8 here. So we can divide this by 4. You can also divide this by 4. Okay? All right, so here we get 4 divided by 4, which is 1. 8 divided by 4, which is 2. Divide the 3 and the 15 by 3 each. So these are the common factors that we're talking about. It doesn't have to be like on top of each other. They can be across as well. Okay, that's perfectly fine. That's usually what happens the majority of the time anyway. So we could take 3 divided by 3 and 15 divided by 3, and that's perfectly fine. So long as we balance things out, then that's okay. One on the top, one on the bottom. Okay. So here we have 1, and 15 divided by 3 is 5. And so here we get 1 times 2 over 1 times 5. So we multiply straight across now, because now we've done the reduction. So here we get 2 over 5 as our final answer. Okay, good. Are there any questions about that? Any questions at all? No? Okay. All right. Well, very good. Okay, so that will take care of it for today. Okay, I'm going to end off here for today because that's where the first class ended off as well. So for next time, we're going to go ahead and finish up here this particular section, section 2.5. We'll also do 2.6, 2.7, talk about division and I believe addition, subtraction as well. And so we're going to get into those two sections as well. Again, priorities for today. Get your test done, get your chapter 1 homework done. But if you have kept up to date here, then the 3 sections that we covered here today, sections 2.3, 2.4, and a part of 2.5. All right, I don't expect you to totally get 2.5 here, but if you are working at the pace of the course, then this is where we're at right now. Okay. All right. All right, don't forget as well, make sure to hand in the work here through D2L. Okay? So I do need to see the work here underneath the assignments tab in D2L. And you'll see chapter 1 test work. All right, any questions about any questions? Any more questions? None? Okay. All right. No, thank you. All right. So we're going to end off here for today. All right. Thank you guys very much for coming out to the stream. I'll be having office hours a little bit later, so please email me if you have any questions or you'd like me to help. All right. Thank you again, and I will see you all on Thursday. Yeah. 2.1 to 5, yes. That would be if you want to keep up with what we've done so far. Correct, Hisa. All right, everybody. We will see you all later. Again, email me if you have questions. All right. Have a great one, and we'll talk to you later, everybody. All right. Take care of yourselves. Okay.